Welcome. Today we will see how to solve this problem. Look at this problem. I'll just read it out. A simply supported beam of span 12 meters carries a UDL of 20 kilonewton per meter over its central 6 meter length. Using influence line diagram, find the bending moment at 4 meter from left support. Okay, so now we want bending moment at 4 meter from left support in a span of 12 meters. So draw a beam with 12 meter span. Okay, now locate this section 4 meters. So making this into 3 equal parts. So this locates the section X. Let this be AB. This is section X. Okay. So this is where you require 4 meters location. You require bending moment. Okay. So we need to find bending moment at 4 meters from left support. Okay. Now, so let us draw ILD for bending moment at this section first. So drop these points. Right. So now this will be our x-axis and this will be the ordinate under the section. So we have learnt in previous videos that how you draw ILD for bending moment. So this is the way we draw ILD for bending moment. Right. So this ordinate, okay, let us calculate the ordinate at X. Okay, so as this is 4 meters, the rest of the span will be 8 meters. So from the formula A into L minus A divided by L, 4 multiplied by 8 divided by 12 will give you 2.667. So this ordinate is 2.667. Right. Now look for the loads, where the loads are being placed. Now you can see there is a UDL 20 kilonewton per meter over central 6 meter length. Central 6 meter length. So let this be the midpoint, center C. So 6 meters, central 6 meters, okay, which means 3 meter to the left and 3 meter to the right. Okay, so let this is 4 meters, right? This is 2 and this could be 1. So I draw UDL like this. Okay, so this is the center and this is, let us say, location D and E, ends of the loads. Okay, so now this is central 6 meter span. So from center towards left it is 3 meters, towards right it is 3 meters. So it is placed in such a manner as explained. Okay. Right, now you drop these ends onto the drawn ILD. Okay, same here. Right, let those ordinates, these points, or YD YE. Okay. Now if you want bending moment, this is ILD for bending moment. Now if you want bending moment, we need to multiply the load value, that is 20 kilonewton per meter, multiplied by the area occupied by the ILD. So this is left part of the section and this is right part of the section occupied by ILD. So you need to calculate these two areas, like let us say this is 1 and this is 2. So now I want bending moment at section X, which is equal to load multiplied by the area occupied by the UDL. Okay, so I need A1, the area A1. If I want A1, I need YD value. So let us calculate YD value. Okay, so YD is equal to, now you can see this distance is 3 meters. This is 4 meters. Okay, so it is 3 by 4 times 2.667. So it comes out to 2.0. Similarly, this you can see is 3 meters and this you can see it is 8 meters. So YE comes out to, from similar triangles, it is 3 by 8 times of 2.667. This comes to 1. Okay, right. So once we get these values, now we are able to write the areas. Okay, now you can see this is, I will go with a different color. See, this here is 1 meter and this one here is 5 meters. Okay, now A1 value is equal to the two parallel sides average, that means 2 plus 2.667. this is YD value is 2. Now you can see it here, YD is 2. This 2.667 average multiplied by the distance between the two parallel sides is 1 meter. So this value comes out to 2.3335. Similarly, the area, second area, that means to the right of the section, area of trapezoid is equal to 1 plus 2.667 by 2, average of two parallel sides. 2.667 is this one and YE is 1. Multiplied by the distance between them is 5. Okay, so this comes out to 9.1675. Okay, now 20 multiplied by A1 is 2.335 plus 9.1675. So put together it is 230.02. So this is because of this rounding of numbers. Okay, so neglecting that, this will be 230 kilonewton meter. Okay, so now the answer for this question, we used ILD. Bending moment at 4 meters from left support, bending moment at this location is 230 kilonewton meter. Okay, so this is how you need to use the ILD for calculating bending moment at a section. Right, thank you.